Trig word problems, part one. Here we go. Everyone's favorite. So in this video, I'm going to go over the first trigonometry problem that's a bit more advanced than what you might have seen before. It's a pretty typical looking question, in your kind of pre-calculus 12 class or your more advanced trigonometry, right? We're starting to look at graphs of trig functions rather than just looking at triangles. So anytime you see like an oscillation or a repeating pattern, right? We see it all the time in nature with ocean waves or, sound waves, any type of wave. Or in this example, someone is jumping rope at the gym, right? You might be doing a Ferris wheel, which is my next example. So let's jump right into it here. Joanna is jumping rope at the gym. Okay, she's trying to get the calves going, right? She's at the gym jumping rope. It takes an average of 0.8 seconds for her to complete each jump, and she typically jumps about 12 centimeters off the ground each skip. Create an equation to model her approximate height off the ground in centimeters as a function of time in seconds. Then estimate A, her height 15 seconds into the workout, and B, the times in the first 3 seconds that she'll be 10 centimeters off the ground. Okay, so lots of information here. Let's just kind of break it down. So I'm going to draw a set of axes here. Okay, so I'm going to call this the time axis, right? Because that's the independent variable we're working with. And I'm going to call this the height, or h of t, right? The height per given time. So we know that we can set up kind of these graphs however we want. Let's assume that she starts on the ground at time equals 0. Okay, so she starts on the ground and then she jumps into the air. She jumps into the air, reaches her maximum, comes back down, hits the ground, jumps into the air, hits her maximum, comes back down, hits the ground. Okay, so what do we know? We know that this is at 0, right? We know that the maximum is 12 centimeters off the ground. So if we drew a line kind of to symbolize where the maximum is, this would be 12 right here, right? We know that the midline is just going to be the max plus the min divided by 2. And since the minimum is 0, it's just going to be half of the maximum, right? So the midline right here is just going to be 6 centimeters off the ground. Okay, and we also know that the period, or the time it takes for her to complete a full rotation, is 0.8 seconds. So we can draw it from one peak to the next peak. This is going to be 0.8 seconds. Okay, and just with that information, we can come up with an equation. Okay, that's all we need to figure out an equation. Let's get right into it here. So kind of the basis to set up an equation is you need all your transformation variables. So we have our A, right? We have either sine or cosine here, times B times x minus c plus d. And instead of x, I'm going to write t because that's our variable, right? So A is just the amplitude, right? B is what we're factoring out to, that B is just a scaling factor that we can figure out from the period. C is just our horizontal phase shift, and D is our vertical translation, right? So how do we figure out what we put in after the A? Well, we have to look at what the graph actually looks like. So notice how the graph is starting at the origin of 0 and it's coming up, right? Oh, it's coming up and it's going to her maximum. She's starting on the ground. She's jumping straight up into the air to get 12 centimeters off the ground. So since she's starting at the origin, her minimum height, and she's going upwards, that looks to me like a negative cosine graph. Okay, so I'm going to put a negative in front of the A, so it's negative A times cosine B. Okay, and what's our amplitude going to be? Well, our amplitude is 6, right? Because it's just the midline down to the minimum or up to the maximum. And the distance from the midline to either of those points is 6 centimeters. So we can rewrite h of t, right, as being negative 6 times cosine of, okay, so b, our b value is going to be 2 pi divided by our period. Okay, that's kind of a formula that's super helpful we can use. And similarly, P is also equal to 2 pi over B, right? It's just a formula, some formula rearranging. So B equals 2 pi over the period, and the period we know is 0.8 seconds, right? That's how long it takes to complete a full cycle, a full jump. So this is 2 pi divided by 4/5. That's like 2 pi times 5/4. So that's 10 over 4 we can reduce to 5/2, or 2.5 pi. Okay, so that's how we can find B. I'm just going to plug that in here. So that's going to be 5/2 pi. Now, what is our C value? That's our horizontal phase shift. Well, we chose this negative cosine because we know that we started at the origin and we went up. So that was going to be super helpful for us because there's actually no phase shift the way we've drawn it, right? Maybe if we chose like a positive cosine or a sine graph, maybe that wouldn't be the case. But since we chose a negative cosine specifically, this C is just going to be 0, and we can drop the brackets entirely and just write T here, right? And so now we're going to add our vertical stretch, or not a vertical stretch, our vertical translation, right? And that's going to be the same as our amplitude because we start at 0 and we're moving upwards. Our midline's at 6, but our amplitude is also 6 because if we go from the midline down to our minimum or maximum, we will get 6. Okay, so this is our equation right here. For any given time t in seconds, we can plug it in for t, and we'll get h of t, which is her height above the ground at that given time. So now we can go into question A. What is her height 15 seconds into the workout? Okay, so 15 seconds, that sounds like a time to me. So that means we don't know height, which is what we're looking for, right? We're looking for her height 15 seconds after she starts her workout. So at 0 seconds, she's on the ground. Her height is 0, but what's her height 15 seconds after that? So all we do is we plug in 15 for t, right? Because that's our time. So it's not super strenuous because the hard part was coming up with the equation. Now that we have the equation, this is easy money. All we do is plug in 15 for t. Okay, so I'm going to multiply 5/2 pi by 15. So 2.5 times pi, right, times 15. We take the cosine of that. Okay, we multiply that by -6. And then we're going to add 6. Right, and I'm just going to make sure I'm in radian mode here. Always make sure you're in radian mode when you're doing these questions because it looks like it could have messed me up here. Okay, so we have 2.5 pi, right? And we take that, we multiply it by 15. Here we take the cosine of that, multiply it by -6. Okay, so there's some kind of wonky with my calculator here, but what you'll find is if you plug in 15 for t, you'll get approximately, for rounding, let's call it 6.05. Okay, so this is 6.05. And this is centimeters off the ground. Okay, so that's part A, right? And now I'm just going to write A here. And for part B, it's saying the times in the first 3 seconds that she'll be 10 centimeters off the ground. Okay. So what we have to figure out is when's the first time that she'll be 10 centimeters off the ground? So all we do here is we plug in, instead of h of t, actually we're going to put 10 because that's her height. Right, and now we're trying to solve for t. Instead of being given t, we're trying to solve it. Halves pi t plus 6. So remember this 5/2 pi times t is all inside the cosine, right? And then we're adding 6 there. Okay, so what's the first step that we can do when we're trying to solve for our time here? So see how the time is kind of embedded inside these brackets? The first thing we can do is kind of work inside out. So I would get rid of this 6 on both sides, so it's 4 equals -6 cosine, right, 5 over 2 pi t. Okay, and like I said before, we're working from the outside in. So I'm going to divide by -6 on both sides. So that's going to be -2/3. Once we kind of simplify that, so now we have cosine of 5/2 pi t, right? And the next thing we have to do to try and get t on its own is take the inverse cosine of both sides. So then we'll be left with whatever's inside here. Okay, so if we take the inverse cosine of -2/3, right, that's going to give us the inside of the right, which is just 5/2 pi t. Okay, so if I go into my calculator here, and I take the inverse cosine of -2/3, right, I get approximately 2.3. Okay, so I'm going to write 2.3 here. That equals 5/2 pi times t. Okay, so now we kind of totally got rid of that trigonometric function, that cosine, right? So now it's just basic algebra. All we have to do, if we're trying to get rid of the 5/2 times pi, we just divide by 5/2 times pi, right? So if we divide by 5/2 times pi, it'll cancel on the right side, so we're just left with t. And on the left side, that's what our calculator's for. So if we take that, and dividing by 5 over 2 is the same as multiplying by 2 over 5, right? 2 over 5 is 0.4, so I'm going to multiply by 0.4, and then I'm going to divide that by pi. Okay, so once you divide it by pi, you'll get that it's 0.29 seconds. Okay, that's the first time in which she reaches 10 centimeters off the ground. Okay, now if we go back up here, right, we know that this is going to be, one thing I wanted to emphasize here is that this is 0.4, because if from the start, right, to the first full cycle, this is 0.8, half of that is going to be at 0.4, right? So it's not 0.8 right here. I kind of drew that a little weird. 0.8 is just the difference from each peak to the other. So if this right here, say, was 10, that's what we just found, right? The time here corresponding to 10, that's going to be 0.29. Okay, so I'm going to redraw it down here actually to make it a little easier. So this is our function, right? This is our h of t, this is our t. Okay, and we know when she's 10, I'll zoom in here. When she's 10 centimeters off the ground, right, this is 10, we know this is 0.29. Okay, and we know that exactly halfway between, like kind of splitting the wave in half, this is 0.4 right here. So what's the difference from this line on the left to this line that kind of splits the wave in half? Well, we can just do 0.4 minus 0.29, right? And this will give us 0.11. So we know that on this side, right, if we were to draw the line right here, right, where it's also 10 centimeters above the ground, because it's kind of a line that goes straight across, this will be 0.11 more than 0.4. So since these waves are symmetrical, that's kind of useful. So we know this is going to be 0.29, it's going to be 0.4 right in the middle, and it's going to be 0.51 the next time she's 10 centimeters off the ground. Okay, so the most important thing is that we know from that point of symmetry, it's 0.11 to the left and 0.11 to the right. So they wanted us to list the times in the first 3 seconds that she'll be 10 centimeters off the ground. Okay, so I'm going to erase this nasty junk here. And we can kind of redraw it. So we know the first time's at 0.29. I'm just going to draw a big. So if this is 0 seconds, right, we're drawing a bunch of iterations for her jumps. So this is 0.4. This is 0.8 seconds later. It's going to be 1.2. This is going to be 2. This is going to be 2.8. And this is going to be 3.6. We're looking for all the points where she's 10 centimeters off the ground. Okay, that's what we're trying to do. So it's going to be right here, right here, right here, right here. There's going to be all these points. Right, and it's going to end at 3.6. So this will be our last point over here. So we know this is 0.29. This is 0.51. I'm going to zoom in a bit here. We know our next midline is going to be 1.2. So if we go 0.11 to the left of that, right? So if we have 0.4, so 0.11 to the left of that will be 1.2 minus 0.11. So this will be 1.09. And to the right of it, it'll be 1.31. And we just keep doing that. So for 2, we go 2 minus 0.11. Or sorry, 2 minus 0.11. So that'll be 1.89 and 2.11. And 2.8 minus 0.11, that'll be 2.69. So it's kind of repetitive. And then 2.91. And then finally our last point will be 3.6 minus 0.11, 3.49. Okay, so this is a very rigorous question, but we just had to list all the points in which she was 10 centimeters off the ground. So all these numbers right here are the times in which she is 10 centimeters off the ground. Okay, so we do that by inserting 10 for our height, because that's what we were given. And now we're trying to solve for t, right? So our first time we can solve algebraically, right? We kind of work from the outside in to figure out our first time. We know it's 0.29, but that's not our answer, right? Because it's 10 centimeters off the ground multiple times, as you can see. So the first one is 0.29. We can solve that algebraically, but the other ones, we have to split this wave down the middle to figure out how far to the left and how far to the right of each designated time she'll be 10 centimeters off the ground. So there's not really an easier way about to go about doing this type of question, but I hope that this kind of method and explanation was helpful. And I'll see you in my next video for our second example where we talk about Serena on a Ferris wheel. Okay, thanks for listening. See you soon.